much interest to go into research. However, for some of us that are not doctors yet, but we inspire to be one someday, we have interest in research. So I was looking at if there's a platform for mentoring, which they said it during the launch of the Auto Up Club. They said something about the mentoring. So I wouldn't know how far the preparation is going, because when interest like this comes up and then you don't have like a backup, a follow-up to push it further, you realize that the interest start going down. For some of us, we really have interest in research, and we can't just do it like that because research is quite broad. So we'd like to like a part where we have a model we are working with, like something we can really expose to. For instance, like it comes to research. I know during a undergraduate level, we have something they call assistant lecturer, teaching assistant, and all of those research, like they are just carrying them along so that they get exposed to it. So I wouldn't know how far the mentoring section have been planned, but then I would like to be part of the, like, one of the mentees so that we'll grow from there.
Thank you so much. But just before you mute, when you say we're not all doctors here, do you mean doctors as in doctor medical or doctor PhD? So I can quickly correct.
Where I would say research PhD, and I know a lot of persons here are really high, but then we just want to, like us that are just graduate and we have interest in going further. So that was what I meant by doctors.
Okay, all right. Because I thought you were on under the impression that everyone on the team is a doctor, but we're all a mix of medical. In fact, our principal investigator is a PhD doctor.
Research,
Exactly.
PhD, yes. Research,
all right.
yes.
Thank you. Thank you.
Thank you so much.
Yeah. Thank you so much. I'm so happy you spoke up. This is part of our plans, but as you're aware, it's a new project. And if you followed the launch, that's one of the projects we're planning, do a mentor-mentee matching. Do a mentoring program. And inside the mentoring program, we will have a mentor-mentee matching thing. And another good news we have for you, especially for those of you who are lecturers already, is we've noticed that a lot of the complaints that people have when they join academia is, number one, most of them are not aware of the promotion criteria until the promotion is upon them and they end up missing their first promotion, either because they couldn't get the requirements together on time or they were late in knowing about the requirements. So one of the things we want to do is, once you join, we're able to find the right group for you so that we can mentor you, make sure you know about the requirements on time, and make sure you get the requirements on time, and then make your first promotion. And what you're going to use to pay us back is to join as a mentor. You were mentored to make your promotion, then you would join back to pay back, mentor at least one group, and then you can decide to leave if you're no longer happy being a mentor. All right, so thank you. Yes, that's very important. That's part of the things we're planning to do. Thank you. So whilst we're still waiting for our resource person, is there anybody else who has any feedback for us? We're noting all of this and it will help us to improve. And whilst I'm waiting for another volunteer, for those of you who are aware, Author Aid started off with 3 online journal clubs. There's the journal club I coordinate, that is for biomedicine and healthcare. There's one coordinated by our principal investigator, Dr. Doherty, in the sciences. There's toxicology, there's chemistry, environmental chemistry, and biology. And there's a third one, but the coordinator is in Kenya, but we're all interlinked. We have an idea what's happening in all the journal clubs. So my journal club, Biomedicine and Healthcare, we're going to have our relaunch on the 30th. And we're going to, as part of the relaunch, we're also going to have a journal review. So we're inviting everybody. You do not have to be in biomedicine and healthcare to participate. You can participate and you will learn a lot because we have a mix. Sorry, let me mute. There's a lot of noise from the background. Okay, all right. So so we're going to be joining on the 30th. I think I posted the flyer on the national hub group. I'll do that again. So please, if please remember to join us. It's on the 30th. The hosts, sorry, not the hosts, the authors of the paper will. So if able to make it, as we like to do, then the authors will be there. So in case if you have any problems with research design, you'll be able to address it to the authors. The authors of the paper are Egyptians. All right, thank you so much. So Mr. Shaw Suleiman Adediro, please speak. Your hand is up, Mr. Shaw. I've asked you to unmute. Please unmute and speak. Maybe he stepped away from his computer or his network is not letting him unmute. Mr. Shaw? Mr. Shaw, you can speak. Okay. Brian, how are you? Please speak if you're available. Mr. Shaw might have stepped away from his computer. Sometimes when the network goes wonky. Hello, Brian. Hello. How are you?
Hello. How are you? Long time.
Yeah, it's been a while.
Yeah, indeed. I last heard from you on one of those. I think the tea moments.
Yes,
yeah,
tea time.
The tea time.
Yes.
Yeah, but I've been having some bit of busy times as a student. So I failed to catch up with those other sessions that you organize. But on a personal level, okay, I'm a medical doctor in Uganda, and I'm a student.
What's the time?
If I remember properly, you're from Zambia, Mika?
Yes, I'm a medical doctor from Uganda.
Uganda, okay, yeah, sorry about that.
Yes, and currently I'm a student. I'm pursuing my master's in epidemiology and biostatistics. And
fantastic.
Yes, at Makerere University.
Oh, okay. One of the author stewards is there, Macquarie, Dr. Yes. Richard Degrees. Have you spoken with him? Have you met him?
The institute is too big that I only know people who are within the department of who are within the department of clinical epidemiology and biostatistics.
Oh, okay.
But I find the platform very interesting because we know learning is continuous, and
Sorry about that, Brian. I was trying to mute somebody and then your name popped up. Just give me a second. I will unmute you shortly.
I think I've unmuted myself.
Okay, good. All right. Thank you. Technology. Thank you.
Yeah. Yes. So I was saying that the platform is really interesting, and it's a very good platform, I should say, with a lot of learning opportunities here and there, especially in line with research, and for people whose career path is along research. I think so far we are doing very well because a lot of learning opportunities keep coming through from all corners. And because we know learning is continuous, and we learn by doing, and we learn by doing the same thing several times, and then become experts at it. I think we can only keep it up, keep up with the pace, and I've always been. It has been a pleasure being on this platform, because every day seems to be a learning experience, because the learning opportunity never cease. Thank you.
Thank you so much, Brian, and congratulations. If I'm not mistaken, when you joined Author Aid, you hadn't graduated from med school, had you?
No, I had already graduated.
Oh, you had? Okay, all right. Sorry. That must be.
I graduated in 2020.
Okay. All right. There's one other person, but I think that's the person from Zambia who is in, I think, final year. Yes. All right. Okay. Thank you so much for the kind words. Thank you. I don't know if Adediran has been able to mute now. I've given you permission to unmute. Mr. Adediran, are you still having issues? Okay, so is there anybody else who would like to speak? What have you learned from Author Aid so far? What are your expectations from the hub? And what would you like us to do more of? We love the feedback. That's how we can grow. Whilst I'm waiting for somebody to speak, I'll try again to get in touch with the research person, with the resource person, Mr. Agada from Penelua Educational Consult. Thank you. I just got off now. Okay, all right. Okay, all right. Thank you. Sorry to put pressure on you. I know you must be flustered. All right, thank you. Okay, so I got good news. He said he's been able to sort out his power supply issues and will be joining us shortly. Thank you. Brian, because most people here are here because all of us are trying to learn data science 101. And I'm so happy that you've informed us that you are a data scientist. So we're going to be calling on you very frequently for our sessions so that we can have a large pool of data scientists in our hub. Of course, it's called the Nigerian hub, but it's open to everybody who can help, especially as a mentor. We have a large pool of mentees, and the more mentors we can have, the better. And as you said, when it comes to learning, the more the merrier. Participants that I'll be calling you frequently. Thank you. Okay, let's see. Has he been able to join? Not yet. Mr. Oshoa, you're still online. You can join us. You can speak up. The resource person is just signing in. I've asked you to unmute. Are you still there, Mr. Oshoa? I think there's a problem. Okay. Somebody was asking who posted that. Lawan Abba, you were saying something about Aurelia. Is there something you'd like to know about Aurelia Munene? Mr. Lawan Abba, you always posted Aurelia Munene in, or was it when I was talking about the journal clubs? Yes, she is one of the coordinators along with Joyce Wangari. I'm sure if you've been following the major author aid, especially the tea times for any length of time in the last like 1 year, I'm sure you have heard from both of them. They're both Kenyans. They run the Social Sciences Club. So those that along with the biomedicine and healthcare and the environmental sciences one were the first 3 that started. Then a few others have sprung up. I am aware that the social sciences one, there's another one. I'm also part of that, the Africana Journal Club. And then there's a climate related water journal club too. Thank you. So please, let's be a little patient. He's assured me that he sorted out the issue and will join us soon. Okay. I need to make some adjustments while we're waiting. Okay, so somebody is asking about the link to the journal club. Okay, climate change journal club. Unfortunately, I don't have the link to that, but just stay abreast of information on the National Hub WhatsApp group. As soon as that is launched, we will let you know. We're going to publicize it there because myself and Dr. Doherty are going to help the journal club take off when it's starting. So just keep abreast of information on the group. Thank you. All right. So let me make a few more people co-host. Edition, yes, please.
Good morning, ma'am.
Morning, Edition. How are you?
Fine, ma'am. Okay. Hello?
Oh, great. Mr. Gada has joined us. Yeah, so Edition, you're going to need to speak a bit fast. Just make your points quickly. Our resource person is here finally. Thank you.
Okay.
So Edition, please speak.
I want to publish my project. I'm writing a project, so I don't know a particular journal in which I can publish my project work. I have like 3 project work on hand.
What's your
Hello?
major? What's your major?
Public health.
Public health.
Yeah.
So what will happen is I'll find time during the course of this workshop to find the link for you to, are you on the National Hub?
Yes.
Okay, all right. So could you send me a private message from the National Hub so I can put you on the biomedicine and healthcare group? Yes, and from there, I have quite a number of people that can mentor you, and then you can publish your paper. But this will be part of the national project. And one of the things we're requesting from everybody is please, when the National Hub has been part of you achieving your research goals, please just acknowledge us. And because sometimes we might be calling on you for maybe the tea time so that you can come and say a few things so that we can get more support for this project. Thank you.
Thank you.
Thank you so much. So Mr. Agada, you're welcome. Yeah, you're welcome. You're welcome. So Mr. Agada, you're welcome. We've been waiting for you, 60 people waiting for you. So once again, let's do the reintroduction. My name is Dr. Zainab Yunisa Kaltungo. I'm the Northern Hub Coordinator for the Author Aid National Research Hub, Nigeria. The National Hub Research Hub is a project funded by Author Aid, and it is domiciled in Yaba College of Technology, specifically in the TETFund Center of Excellence. And the principal investigator, the coordinator for the national program is our able Dr. Doherty, indefatigable, as we say in Nigeria. Dr. Doherty, she's here. She's a very senior lecturer in Yaba College of Technology. And thank you again, Mr. Agada, who reached out to us. And this is one of the aims of the National Research Hub, for us to bring as many Nigerian researchers together under one umbrella, so that as many people as possible can bring in their resources. You as a mentor can mentor somebody, and when the mentees when they achieve their aim, they can in turn join as mentors, and then we're going to have as many. Could you please mute? I'm finding it difficult to mute some people. Could you mute? When they achieve their aim, they can. Okay, all right, thank you. I think I've muted where the noise is coming from. Good. So without further ado, thank you so much, Mr. Jeremiah, who volunteered to do this. In fact, he more than volunteered, he actually pushed for this workshop to hold, and we're so glad to have him. So Mr. Agada is the CEO of Penilua Educational Consult, based in Kaduna, Northwest Nigeria. What he does, I'm going to let him introduce himself, but essentially what he does, he's a private startup that does mainly research and statistics backup for researchers. But he's going to introduce himself a little more. I think I've done enough talking for today. Thank you so much, Mr. Agada. Can you unmute and speak? Let me look for you. Can you unmute, or do you need host permission? I don't think you need host permission. Okay. Technology has thrown him out again, but don't worry, we'll overcome. Thank you. We're getting a lot of questions about how to join the National Hub, how to join the journal clubs. So for the National Hub, Dr. Doherty has correctly answered the first question about how to join the journal club. So reach out to the coordinators, myself, Dr. Kaltungo, and then Dr. Doherty. Those are the two journal clubs that are within the Nigerian Hub. But that doesn't exclude you from joining the social sciences or the climate change one that is coming up that are not primarily run by Nigerians. You can still join, but the two journal clubs that are run by Nigerians, the biomedicine and healthcare that I run, and that's run by Dr. Doherty, the environmental sciences, are run by Nigerians, and they're within the hub. We have incorporated them into the hub for maximal impact. So please reach out to us, send us direct messages, and then we'll add you to the hub. We'll add you to the journal clubs. And for those who want to join the hub, I'm going to the National Hub. I'll be sending a link shortly so that you can join. Thank you. Jessica, can you hear now? Jessica, okay, dear, I'm sorry, I hope I pronounced that right. Can you hear us now? You said you can't hear anything. Nobody else has complained about any audio issue. Can you hear now? So we can sort out any problem we can from our end. Please respond in the chat box. He says his network is unstable. Recall I said he had to change location. So the network at his location is really poor, but he's trying to join again. But whilst we're at it, for anybody who knows, who's been part of our journal club or has been part of Author Aid for any time, you know our own data science guru, Mr. Felix. So let me put him on the spot. If he can tell us one or two things about data science whilst we're waiting for Mr. Gada. As soon as Mr. Gada comes, I'm going to let you off the hook. Mr. Felix, I'm going to make you co-host. I had to put you on the spot. So I've made you co-host. So please,
okay.
Thank you very much.
Hi,
Compliments of the season to you.
Yes, compliments of the season. Yeah, how is everyone doing?
We're good. Thank you.
Okay. All right, great, fantastic. So the interest of data and data science has continued to grow. And the reason is because a lot of the things people do today are evidence-based. I know we may say, oh, when you take a flight from wherever you are going to, I mean, local flights for those in Nigeria, when you arrive at your destination, you usually get this survey, just to know, things about the flight, how you liked the flight and the rest of them. But these days, they don't do it in flight anymore. Even if you take some local buses, interstate buses, when you get to your destination, you get a message to know how you enjoy the ride and the rest of them. Just to show you that the awareness to use data or information to make decisions for company growth is becoming very, very relevant. So we would not be able to hide that anytime soon, because people are becoming aware that data is key. Another example I can give, like for those that work in a corporate environment and there's a decision to make, and let's say now, if your organization have meetings on Monday or on Tuesday, there's these weekly meetings most organizations have, and you want to set a time for that meeting. How it's usually done before, it's probably the boss's wife or the boss's brother or someone in the high, in the high cadre of that organization would say, oh, I think 10 a.m. will favor me, or I think 9 a.m. will favor me because I have to do school runs or whatever. So that favors me. So I think we should circle our meetings around that time. And you find out that even if the rest of the team agrees, because they don't want to offend the boss or offend someone in the high seat, but you find out people come to that meeting with grudge. But if that singular act was informed by data, which is simple, you do a survey, a simple survey, and you send the link. The staff, they don't even have to be there. They just get the link on their WhatsApp or something. Please, we want to schedule a meeting for Monday and we want to seek an appropriate time. These are the time options that are available. And you fill in your time options and you send. And you find out that at the end of the day, you see the stats or you see the graph and say, oh, from the summary of this survey, this is where majority of the people or majority of the staff, their decisions are based. you find out that when that time is slated, nobody will frown, nobody will grudge, because data is informing the decision on what time we're going to use for that weekly meetings. So you see the benefits of data. You know, that's why someone said that any decision you make without data is just an opinion. You know, so I'm happy that we're all here to actually build our interest in this very important field that is revolutionizing our world, whether you're in Africa, whether you're in Europe, whether you're in America, anywhere you are, everybody is looking out to use data to make informed decisions. So I'm happy you're here, and thank you very much for the organizers of this, especially Dr. Zainab, and also the author, the National Hub, which we are motivating ourselves to see how we can get a lot of researchers like you become interested and begin to mentor others too. So if you're interested in working with us, please reach out to Dr. Fumi. She's here, and some of the links will also be shared in the chat box. You can take advantage of it and see how we can build the research capacity of our country, extending it to other nations. Thank you.
Fantastic. Thank you, thank you, thank you, thank you so much. Thank you for that. So Mr. Gada, we're ready for you now. Thank you. We can see the keyboard of your laptop. So that means it looks like your laptop is up and running. Thank you. Please start. If you can just give us a little introduction of, tell us who you are, and then where you're located, what Pennyloa does, maybe in about 1 minute or 2 minutes, and then you can start the workshop. Thank you. Once again, everybody, apologies for the delay in starting. Thank you. Mr. Gada, are you there?
Thank you very much. Can you hear me, please?
Yes, we can. Thank you.
Yes, we can hear you. Okay.
So I'll make you co-host so you'll be able to share screen.
Unfortunately, I may not be able to share my screen now.
Okay, no problem.
I've had so much here. So I will do my best to just try and see if I can just do some presentation outside the screen. But hopefully, by tomorrow, I'm going to do everything I was supposed to do today within a few minutes, so that we can catch everything together. I sincerely apologize for the delay so far. I am so sorry. It wasn't intentional. To start,
it's okay. We're all in Africa. We know. Go ahead, please.
So to start, I am Jeremiah Agada, the CEO of Pennyloa Educational Consult. I am a data analyst and a consultant for researchers. We do so much of data analysis. We help people see their work through, collecting data, transforming their data, make them see certain things that they can get from their data, just aside from just looking at an overview. And that is my intention here. We want to see how we can maximize the data that we have and how we can present them in the best possible way. Now, interestingly, I am going to be talking about analytic tools, and then I'll also be talking about statistical tools, and then data cleaning. Unfortunately, I cannot share my screen. Otherwise, I would have shown us practical way of cleaning data. But I'm going to do that by God's grace tomorrow when we have the next session. I'm going to compress everything. I believe we'll be able to achieve all together. Now, the various analytical tools that we have are SPSS, Excel, Starter, Origin, as many as you can imagine. Excel is one that many people don't know about. Many people are not so much aware that Excel, although there are people that go to study so much about Excel and try to use Excel to manipulate data, but it's also a statistical tool. Then R, which we learned a few weeks ago, is also a statistical and analytical tool. And then Python is one. And then many others. There's the SAS, there's the Stata. Many people don't know how to use this, but these tools, it all depends basically on what you really want to do. There are certain tools that would not do certain things, or they will not be convenient to achieve certain statistical analysis. So your knowledge of each of them will help you to choose the particular tool. Now, SPSS is handy, and that's what we want to use. We'll be using it by tomorrow. It is handy to use. It is easy. Everybody can manipulate it. Just maybe within 15 minutes of learning how to use the simple interface of SPSS, you will know how to do one or two things with it. So that is where we're going to be concentrating on. But in the first place, we are going to look at other things. Now, if you know the software called Origin is a software, many people don't know about it anyway, but it is used for graphical presentation. Now, aside from what Excel will do, aside from what SPSS will do, there are some manipulation you cannot do with SPSS on your graph. That means to do some kind of editing to beautify your graph, maybe a bar chart, a pie chart, or whatever. With Origin, you can decide the coloration. You can choose the kind of coloring you want. You can choose your various legends. You can choose how you want it to look. And if you want beautiful charts, Origin is the plug. And then when you are talking about running some kind of programming that connects with using some kind of functions, Stata is a plug for you, which is also an analytical tool. Getting Stata, some people like using commands. Stata give you opportunity for that. And then if you don't want to do that also, you can go ahead with just using the various tools by clicking, getting your data, uploading your data, or imputing your data, and then just by clicking, following some simple steps, you will get your data analyzed. Now, one good thing about Stata, interestingly, not too long, somebody came, and then the person was a statistician, somebody that is doing his PhD in statistics. He met me, and then his interest was he had several variables, many data. The data were so much, and then unfortunately for him, by the time he was looking at, that's where data cleaning comes into place. Now, by the time he was looking at his data, he discovered that he had several spots in his data collection that were missing. Now, this could be as a result of the person that entered the data, maybe the researcher or the research assistant. Now, the person that entered the data, the person hopefully may have omitted some spots where he was supposed to, or she was supposed to have entered the data. The person missed it. Now, Stata, SPSS, and some other statistical package would help you in a way to predict certain values that can fit in those missing values, that can replace those missing values. That means instead of, for some researchers, they go to the lab and then they take their readings, and after coming out, they discover that, oh, this reading is looking too high, or it is looking too low compared to the other variables around, or the other data around. Now, such a researcher or research assistant may just say, oh, if I have 7, I have 8, I have 6, I'm going to just find the mean and put something there. That's you're introducing bias in a way. You are altering your data collection in another way. But interestingly, with your statistical package or statistical tool, you can, or analytical tool now to say, you can easily predict, you can tell your software to predict outcomes, certain data that can replace that without introducing bias. So when the guy came, he told me, he said, oh, he has this and then he has some issues, and his supervisor wanted him to fill those things. I said, fine, it's as simple as that. So we use Starter to do it. You can use SPSS to do it. You can use Starter to do it. We use Starter, and then we told Starter to bring over 20,000 outcomes, 20,000 possible outcomes that can fill in that the missing values there. That means for every spot that there's no data, it is going to predict about 20,000 outcomes that can fit in that place. So by the time you are running your analysis, you are maybe 95% sure that your data are maybe normal, or they are properly collected, because it is going to help you to fill it. That is what that will do. Then if you look at others like SARS, those that are and e-views, for those in social sciences, you know, where you want to do your parametric analysis or qualitative, where you are dealing with the qualitative or non-parametric, it's the e-views you want to consider, and then just to run certain analysis, certain commands to be able to achieve what your objectives are. Now, my main aim, look at our analysis, and then you cannot just wake up and say, I want to be, without knowing certain statistical tools. Now, this is not analytical tools now. They are statistical tools. In statistics, these are tools you use to achieve certain things, and they could either be descriptive or inferential. Now, if you are dealing with this descriptive, you know obviously that the descriptive statistic has to do with just describing your data collection, your data set. You're talking about your mean, you're talking about your mood, you're talking about your median, your percentage, your quartiles, your percentiles, several of them. Those ones, they just help you to describe, to tell you what is obtainable from an overview. It is from there you can put up a table to look at your frequency, your various outcomes. That's just the descriptive. Now, how do you know what the statistical tool to use? This is a major problem, you see. Interestingly, your objective connects to the tool you want to use. If you know the various tools, and I'm going to take some of them now. I wish I have the opportunity to share my screen. We would have seen them, and then we'll show simple examples of them, but we cannot do that today. So one of the inferential, let me start with the inferential now. One of the inferential tools, statistical tool that you want to consider is ANOVA. Now, everybody talk about ANOVA. I want to do ANOVA, but why do you do ANOVA? Why do you consider ANOVA? Another one is chi-square. Why do you do chi-square? Another one is Pearson correlation. Why do you do Pearson correlation or regression? There must be a reason why you want to do that. Now, your ability to understand the principle behind each tool will help you to appropriate your objective, and then to be able to achieve your aim or to test your hypothesis. Are you comparing means? Are you checking collection of means? Are you trying to work with significant difference? Are you trying to check whether this particular mean is different from this particular mean, or this particular thing that you have done, a particular independent variable, does this have connection with other dependent variables? Does it have a place? Is it influencing, for example, you talk about the age of individuals, and then let's say you're talking about age of people from 60 and above, and then you're talking about a character of smoking, maybe people that are smoking. is there a way we can statistically present to say that people that are above 60 years are prone to smoking, or they are not? Can we say that smoking influences certain characteristics, certain things? Now, it is your knowledge of these tools that will decide which one to take, which one to use. Now, let's start with the first one, ANOVA. Interestingly, if you want to look at ANOVA, you must have had several data that have been replicated. Just a few days, I think last week, somebody sent data, a researcher sent a set of data to me. And then when I looked at it, the supervisor had told the researcher, I said, go and get the student, obviously, go and do ANOVA, run ANOVA, and then try to separate the means. When I looked at it, I knew it was not possible. I had to tell the person, I say, hey, it is not possible. You have to go back to the lab. Otherwise, you have to find a way around it. And of course, we must not encourage finding a way to duplicate data in a way. Cooking data, that's a general way of saying the same thing. Trying to cook data, somebody wants to cook data. So in that way, something that is not there, you imagine it and then you put it. Okay, because I said we have to replicate this data, the person now will go sit down and say, okay, because I have 67 here, I'll go and put 67.5. So that by the time I'm having my mean, it will still be around 67. Now, a statistician would know how to do that, may want to do that. Of course, it is wrong. It is not following a good ethic in research. So I had to tell the person, I said, you have to go to the lab, you have to run this analysis again, you have to run this, do this experiment again, and ensure that you have second variables. On a normal note, as a life science, I'm a life scientist, going to the lab, you know that when you are doing any research, you are supposed to have replicates. Now, where you don't do that is where you now have questionnaire. I'm going to come to questionnaire later. But where you are not dealing with questionnaire, you are doing experiments as an engineer. You are testing possibly the strength of a metal or something. You want to look at replicate. I have this metal. I have similar kind of metal. I pass them through the same condition. I weigh this one, or I measure this one. I measure the second, getting, a value for this particular experimental sample. I'm getting for another one that is tested within the same. I just hope we are. Let's say I am testing paracetamol on rats, and I'm using I'm using weight in milligrams. I'm using that to treat or to test on rats, a lab rat. Now, there is no way I will come and then pick just one rat. Carry maybe a 200 milligrams of paracetamol and inject either in a solution way, or or mixing it with the food as a concentrate. There's no way I'll just give one rat and take a single data. To do is I'll have like 3 rats or 5 rats, and the number of sample size also matters in data analysis also. So if I'm using 3 rats, I'll check the first one. After injecting 200 milligrams in the first rat, injecting 200 milligrams in the second rat, 200 milligrams in the third rat. If I'm using 5, then fourth and fifth. But if I'm using 3, first, second, and third. And then by the time I am taking, I'm checking what the effect of this paracetamol has on this rat. I'm going to check for the same cause. I'm going to check on the first rat, I'll check the second, and then I'll check the third. Now I am having value for the first, I'm having data value for the second, and then I'm having for the third. Now that means it is the same 200 milligrams, but I'm having 3 values. That means I have replicated in 3 places. Now I have triplicates to say. It is now triplicates. So I can now find the mean. The first one plus the second one plus the third one divided by 3. It will give me the mean of this rat treated or tested with 200 milligrams. Now, if I'm doing the same for 100 milligrams, I'll do the same for another set of rats. If I'm doing for 50 milligrams, I'll do for another set of rats. So with that, I can now come and meet Hanover. I can now upload my data that are replicated or triplicated, bring that to my statistical package or analytical tool that I want to use, say SPSS, and then I can now say, okay, I want to find the mean of this. Now, Hanover will now help you. This is now where you want to know the use of each statistical tool, like Hanover. Hanover will now help you to know whether there is a statistical difference or a significant difference among the means, various means. That means by the time I have done my collection of my data, is there a difference with 200 milligrams? That is what Hanover will help you to do. Now, by the time you have determined your mean, you have gotten your mean for the second one, you are also now come confidence interval. That's the level within which you want to trust you are judging in a general sense. The level within which you are accepting error or accepting near perfection. Now, in a way, most times in life sciences, we work with 95% to 99% confidence interval. Some others work with 70%, others work with 80%. Now, that means at the end, if I'm working with 95%, the explanation is simple. If I'm working with 95% confidence interval, it means that is going to be 5. That means I want the best possible outcome to be 95%. So my error margin should be 5. So 95% means that at least I want to be 95% sure of my results, sure of whatever conclusion I am making. That's the idea. Then I am giving room for 5%. That's the 5% extra. The animals are correct, and then I'm giving room for just 1% error in case of anything. Somebody say no machine, mechanical advantage cannot be 1. So at the end of the day, everybody would want to give room for error. Anything can happen. There could be changes along the line. So now your Hanover will help you to separate the means and tell you and say, okay, between 100 milligrams of the paracetamol, I'm going back to now my example using paracetamol, between 100 milligrams rather, and 200 milligrams, there is a significant difference, or there is no significant difference. When there is no significant difference, that's where significant difference comes into play. The idea of significant difference now, if you are using 95% confidence interval, your significant difference is going to be less than or greater than 0.05. It just means 0.5 divided by I don't know. Are we getting me?
At least
Hello?
I am. Yes,
Okay.
I'm getting you. I don't know if the others, can we have 1 or 2 people? AA Nobel. Okay, good. Thank you,
Okay, fine, fine.
Jemio. Thank you. So go ahead. Go
I
ahead.
can
Thank
get
you.
Okay. So the interesting thing is your confidence interval will help you to create a margin for error or no error. Now, I was trying to talk about the 0.05 of a thing. Now, if you are working with 95% confidence interval, you know you have just 5% error. So anything that is less than, you just have to know this. You just, because as time goes on, you must have to apply. You have to apply this. Now, anything less than or equal to 0.05, it's going to be significantly different. It is significantly different. There is significant difference. But if it is greater than 0.05, please just take that. If you need to take notes on that, it is necessary. Anything greater than 0.05, there is no significant difference. But if it is less than 0.05, there is significant difference. Now, by the time you have used ANOVA to check the statistical difference between the effects observed from the rats tested with 100 milligrams and the ones with 200 milligrams. If at the end of the day, your p-value, that is your level of significance, is reading 0.01, if it is reading 0.01, now remember I said when your p-value, your significant difference is less than or equal to 0.05, there is significant difference. But if it is greater than 0.05, there is no significant difference. So that means if you now have a p-value where you tested or you use your ANOVA to check how the rats treated with tested with 100 milligrams and the ones tested with 200 milligrams, and you are getting 0.01, remember 0.01 is less than 0.05. So in this case, your value, the difference, the level of significance between your 100 milligrams and 200 milligrams is significant. There is a significant difference because your p-value, which is 0.01, is less than 0.05. Now, but if you run the same analysis, ANOVA, and then you get 0.11. Now, 0.11 is greater than 0.05. So in that case, there is no significant difference. So this is now to tell us that when there is no significant difference, what does it mean? It means that the observable effects on the rats that were treated or tested with 100 milligrams and the ones tested with 200 milligrams, whatever effect you get were not caused by that paracetamol. But if you are having a significant difference, it means that there is the effect is caused by this paracetamol. And of course, you are going to see, maybe sometimes you want to check the effect on parasitemia, possibly number of parasites in the blood of that rat. For those that are not life scientists, I hope you just bear with me and understand my simple life science explanation. So if you are checking the level of parasites in the rat, by the time you have treated or tested it with your paracetamol, you are now checking your amount of parasites in it. If there is significant difference, it will show you that possibly it eradicated everything, all the parasites from the blood, or it reduced it to a certain amount. I am a life scientist. I worked on mosquito during my MSc research work, and presently I've been on a particular insects, dealing with ants. I got a particular growth inhibitor, and then by the time I tested my mosquito, I discovered that the mosquitoes were not growing. At other points, the mosquitoes were dying. Now, I had different replicates, and then I had different concentrations. So at the end of the day, I discovered, or after every 24 hours, I was observing, and then I discovered that certain number were dying as the day was going. I had a control where there was no application of a chemical or an extract that I got around within the state here. So I had to check and discover that on the control where there was nothing, either a positive or a negative control, where there was nothing, it was devoid of the chemical or an extract. You discover that those ones, anyone that is dying there, they were dying a natural death. Now, in statistical analysis, there's a way you can zero on the natural death, the number of natural deaths that has been observed. Now, and then the ones that were caused by your extract or whatever chemical you are applying, you will now use it to determine your mean. Now, in a nutshell, ANOVA generally will help you to separate, rather to present observable differences among the means that you have. 100 milligrams, 200 milligrams, maybe 50 milligrams, 300 milligrams, whatever they are, is going to help you to know if there are observable differences. Now, as a tool also, there is a way to also differentiate each mean. Which mean is higher, which other mean is lower. From your from a physical observation, you can check the one that is 3.5, you know it will be higher than the one that is 2.4 or 2.5. It will be higher by 1. That's 1.0 or 0.9, as the case may be. Now, but with your mean separation, that's where you now come into LSD, least significant difference, or you come into Duncan or 2 key. I said earlier on that you need your sample size also will influence the kind of tool that you are using. If your tool, your sample size is less than 30, your sample size is less than 30, there is a particular tool that you can use. If it is greater than 30 or from 30 and above, there is also a tool that you can use. Duncan is generally used when your sample size is higher than 30. We're going to run this tomorrow by God's grace. So by the time you have used Duncan is going to separate your means for you. It's going to help you to know. If you look at some research, some people's research work, you will see some of on their data possibly on the table where they have a descriptive analysis. You will see there where the means, on the means, you will see they'll put superscripts, something like that's carrying A, another one B, sometimes A, B, C, C, B, A, B, C, like that. You see those are mean separation. So it is the work of Duncan or 2P that will help you to separate the means, to tell you which one is going to be A, which one is going to be B. There is also a practical way of doing that without using a statistical tool. That's by using your standard error or standard deviation. We use your standard deviation to separate the one that your final value is higher takes A, the one that follows take B, like that, and AB, like that. So the most important thing is you must come to a point where you know which particular tool to use. It all depends on your sample size. It all depends on the sample size. So that is an overview for ANOVA. Then when you come to something like chi-square or MANOVA, there's also the MANOVA, multivariate analysis of So when it comes to maneuver grants, it does similar to what ANOVA would do, but it compresses and gives a grant mean. Find the grant, it deals with the mean of everything and tell you whether among the whole, possibly the whole column, there is a significant difference among them. ANCOVA, analysis covariance also. It's also there. It does the same thing. Now, you can also look at the t-test. There's also the t-test, the place for the t-test. I've taken time so much on ANOVA. The t-test also is another one. Maybe in the next 5 minutes, I'm going to just quickly round off so that for those that want to comment or say one or two things, you can have time to do that. There's also the t-test. The t-test helps you to compare. It compares means. It helps to compare your mean value. So if you have this particular mean and this particular, it could be independent t-test, it could be dependent t-test, whatever. It just compare. It helps to compare. So for an example, for example, rather, if you have, let's get back to my example that I gave earlier on. You have your rats, and then you used let's say you use paracetamol here to check if there is an effect on the rat, and then you use maybe ivermectin, another drug, or vitamin C, another drug to test. Now you want to see if there is the effect that was caused by paracetamol is the same with the effect that was caused by maybe vitamin C or ivermectin. So it is the work of t-test, independent or dependent, whatever it is. It is the effect. It is the place of t-test to tell you whether there is a significant difference between the effect observed due to paracetamol or that observed due to ivermectin or vitamin C. So that is just that. So you are trying to compare two different samples, two different means, and you are comparing whether they are similar or they are different. Now remember, it also goes on that principle of 0.05 if you are using 95% confidence interval. So if you are using 95% confidence interval, you know obviously that if your value at the end of your t-test value is 0.003, you know that there's going to be significant difference because 0.003 is less than 0.05. So there is significant difference. That means whatever value, whatever effect you saw for paracetamol is not the same with the one that you're going to observe on vitamin C or on ivermectin, as the case may be. So that is that. Then there's also the place of regression as also another tool. We have to know the use of each of the tools so that you can know which one to apply. Regression is also there. When you have an independent variable, or rather you have a dependent variable, and then you have several independent variables. You have one dependent variable, and you have several other independent variables. For example, you have age, and then you have educational status, you have certain other variables, and then you have one dependent, possibly income. So you are trying to check if age influences the income of an individual, or you are checking if educational individual his or her income. So income here is one thing which we can say is dependent, while these other ones are independent, are to be independent. So when you have several independent variables, you are testing them, checking if they have effect on a dependent a dependent variable. So obviously in this case that you want to use the Pearson correlation or a regression analysis to do your to check. So in that case, by the time you have done your Pearson correlation or you have done your regression analysis, you will now see if there is also, it works with that same principle, if there is a significant difference, still working with greater than 0.05 or less than or equal to 0.05. So you will now see, sometimes you can ask the statistical package or software to help you to asterisk where there is significant difference or where there is no significant. So at the end of the day, you see something like star. That's what many people put on their appendix in their research work. So you see something like double star, single star, depending on how you whatever outcome you have. So in general sense, where you have an independent variable with many dependent variables, or where you have one dependent variable with many independent variables, you use your correlation or your regression analysis to check if there is a relationship around that. So so far so good. We've been able to check. We've been able to talk just about 3 ANOVA, chi-square. There's even the Ox ratio, the regression, the correlation, and then many more. There are many tools. I believe by God's grace, by tomorrow, I'm just going to run through it on a slide, and then we'll just look at it, and hopefully we can share so that we can use that. So with this knowledge, as I'm rounding off now, with this knowledge, you can look at a particular research. You have your research, you have your aim and your objectives. So your objective, are you trying, you see somebody say to compare. When you are comparing, you're looking at the effect to compare. You need a t-test there, or a Pearson correlation where you have several means and you're trying to check them. But where you just want to do a descriptive statistic or descriptive analysis just to present your something, and then your p-value of ANOVA, you want to check if these are actually different or they are similar. And where they are the same, by the time you are separating using Tukey or Duncan, you discover that your superscript is just going to carry the same alphabet or the same letters. So that is just an overview of what I would like to discuss with me outside my ability to share my screen. Thank you very much for paying attention. Thank you for listening.
Thank you so much, Mr. Jeremiah. Thank you, and thank you again, everybody. Once again, this program was brought to you by AuthorAid National Research Hub, Nigeria. The Northern Arm, Mr. Jeremiah Agada, is the CEO, Pennyloa Educational Consult. And for those who are not aware, the AuthorAid Research Hub Nigeria is domiciled in Yaba College of Technology, specifically with the Center of Excellence, TETFund Center of Excellence. And our principal investigator, or the lead coordinator for this project, is Dr. Fumi Dohati. And also present in the meeting are the other coordinators. I have Dr. Ngozi Osadebe, I have Dr. Iduwaneo, Mr. Felix Emeka that everybody knows about. And I'm not sure if I saw Effiong. Effiong was here. There's one other coordinator who I don't think is here, Dr. Waimi. So once again, thank you very much for the presentation. And I think despite the technological hitch, you still came through very well. So if there are a few questions, I think you can just raise hand and we'll pick you one at a time. And whilst we're waiting for you to raise hands, I'll just quickly indicate some of the comments that were in the chat box whilst he was presenting. The first question was, would you make the slides available? And whilst you're trying to answer that, somebody said that you were a bit fast. I don't know if others relate to it, but I think if you can just slow down a bit for subsequent days, it would be just nice. So thank you. So Mr. Agada, would you make the slides available whilst I call on those that will...
I'm going to do that. I'll do that.
All right, thank you so much. Thank you. And for those who are asking, he had a technical glitch at the very beginning, and that was why we started a bit behind schedule. But he's promised that by tomorrow he will make proper arrangement, because it was a last-minute problem he had. But he's going to make arrangements so that for tomorrow and the day after, we can have the workshop as we have planned it to be. It's going to be an interactive one. So please don't join with your phone, join with your laptop, because it's going to be an interactive session. And most of the things he'll be teaching, you cannot do with your phone. You're going to need a bigger system to do that. So the first person who's raised his hand that I can see here, I hope I got the order right, is, just give me a second. I can only see hands raised. I can't see the person. So just give me a second to scroll through. But the first person, if you can unmute, please unmute and start asking your question while I scroll to the other person. Okay. We're going to make this very brief. We realize people have other places to be. So first person, I can't see whose hand is raised. I can only see that there are 3 hands raised. So who is the first person? Please unmute and ask your question.
Good afternoon.
Okay.
Good morning.
Good morning.
Yeah, I'm not sure if I'm the first person, but
It doesn't matter. Please go ahead.
All right,
Thank
so that
you.
I will not jump the queue. I actually came late, and I must confess what I met was spectacular. Honestly speaking, not for me, not really fast. Maybe because me I'm a fast speaker as well. But the little I met, it was very, very explicit. I must give kudos to Mr. Adaga. I'm very grateful to Auto Aid. It has been very, very explosive for me. That is one. Then two, my question is specifically when he was talking about significance, talking about the p-value, he mentioned that when p-value is less than 0.05, that is we are using the 0.05, that it means that it's a significant difference. And when it's greater than 0.05, it means there's no significance. Now, what I want to ask, he cited an example of, okay, maybe there's a significance, or maybe that's a particular, maybe talk about paracetamol like he cited, maybe paracetamol was working for that particular thing or not, or it's not. But another thing I want to ask is, sometimes we can have a significant increase. Okay, yes, we were talking about parasite. I wanted to get that clear. If we have either the ivermectin or whatever is used in the drug, and it's increasing the paracetamol level of whatever sample is looking at, is it also significant? Because we used to have significant increase or significant decrease. I just wanted to be clear on that. I hope you get that. Thank you.
Dr. Salisu, before you run away, so that people would truly understand the context of your question and how deep it is, could you just introduce yourself? I remember the Journal Club meeting where I met you. I was in awe. So please introduce yourself.
All right, thank you. I am Dr. Mrs. Salisu Isilola. I'm from Olabisi Onabanjo University. A well-bred auto aid. I started my writing career from auto aid, then writing online courses, and since then I've been growing, I must say, and I'm still learning. So here I am again, trying to learn and pick one or two things.
And being very modest. Thank you very much. So question noted. Thank you. Right. So thank you, Mr. Agada. Would you want to answer that, or do you want to take more than one question? We have 2 more questions.
I would like to because I'm not sitting on the table and I don't have a pen and paper here to write down. So let's take them one by one.
Thank you. Please go ahead.
Okay. The idea is you are looking at just differences. That's what you are looking at. Whether it is increasing or it is decreasing, the idea is that the first mean is higher than that the first mean rather is different from the second mean. That's the idea. Whether it is higher. Now, for example, I have the first mean to be 7.89, and then the second the second mean I'm getting is, let's say, 5 point something. So it could be, okay, the more you increase your concentration, the less the number of survivors. So that means, let's say I have at 100 milligrams, I have 9.5. Then at 200 milligrams, because many have died, more will die, I will now be having something like 5 point something. So whatever the case, either increasing or decreasing, ANOVA will just help you to separate, to tell you whether there's a significant difference. That's what ANOVA does. I don't know if you get ma.
Yes, thank you. I'm clear now. Thank you.
All right, thank you very much.
Thank you very much. So the next person, there's Egia. I hope I pronounced that right.
Yes, you pronounced that right. Okay, good afternoon, everybody. My name is Egia Idris Adamu. First of all, I would like to appreciate Mr. Agada for that wonderful presentation. And although there was no screen sharing, but At least thank you for that. My question is that I'm running is regarding ANOVA and Chi test. So it's the work is just variation between predominant blood group and white blood cell count. The lab work has been done. So I'm asking what package would be more preferable for the data analysis? Should it be ANOVA or Chi test? That's just my question.
Okay, if I would ask quickly, what is your objective? What's your first objective? What's the second objective? What's your aim? What do you want to do?
Okay, my aim is to know the predominant blood white blood cell count in blood grouping, in the sense that what particular blood group have the highest white blood cell count among the eight blood group, irrespective of their rhesus factor.
Okay, fine. ANOVA will help you to just give you your mean and then show that there are differences in the mean, but you have to do an inferential. This is inferential kind of statistics. So if you are looking at which one is higher, you have to compare. By the time you have gotten your mean, you get your mean where ANOVA will help you to tell you, okay, there's a difference. Then you can now do a comparative study. T-test will do it for you. Chi-square can also tell you what the problem is. Chi-square will tell you whether there's a level of association. It is not going to just tell you whether there's a difference. It's going to tell you whether, oh, this particular thing, is it associated with this other thing? Is there a level of association between them? Is the same thing odds ratio would do. So in your case, if you are looking at which one is higher, I think you can just stop at ANOVA. ANOVA will take care of that. And then if you want to see if there are differences between between your mean values, then T-test will take care of that. So you should just limit yourself to ANOVA and T-test.
Okay, and again the at the course of the lab work, there are some difficulties I'm getting, and I don't know how to at least present them. It's just like a particular.
Sorry, I'm going to have to intervene here because we're. Excuse me. Egia. Are you on the?
O positive as example.
Egia. Okay. Sorry, we can't hear you anymore, and we're only permitting one question per participant. So if you're on the hub, please can you reach out to Mr. Agada, and then he'll be able to sort you out. So let's take the next question. Mr. Gospel Asoko, your hand is up.
Okay, thank you so much. I really appreciate you, Dr. Jeremiah Agada. My question, not really a question, is a concern. Whilst we are waiting for the major program like major class tomorrow, I would like to know the software we are using so that some of us will follow through as well as we make progress in the course of the presentation.
Okay, every system has Excel, so you should have Excel in your system. At the same time, try and get SPSS. We'll be using SPSS. And then for your information, I'm not yet a doctor. I'm on my way to becoming a doctor. So I'm not yet I'm on my way there.
Okay, thank you.
As we say in Nigeria, he's saying a prayer for you. All right. So
that's a good one. I accept that.
Okay, all right. So before we bring this meeting to a close, so Mr. Agada, if a researcher on this platform wants to get across to you, what's the best way to get across to you? I know you're on the hub, so they can get you there, but what's your name? What's your WhatsApp name on the research hub? And then on what other platform can they reach you?
Okay, you can get me most times. I like mail. I like communicating via mail. That's the best way I like. But WhatsApp,
okay.
I come on WhatsApp.
Can you put the email in the chat box at the end? When you're done speaking, please put the email up. Go ahead. Where else can we reach you?
So WhatsApp is good. I come on WhatsApp once in a while, check one or two things and leave. So whatever message anybody sends to me on WhatsApp, I will obviously see and attend to it.
Okay.
Then
Right.
Instagram, I'm just beginning to just started Instagram not too long.
Okay. All right.
So
All right.
I'm yet to develop it.
All right. So thank you you so much, everybody. If there are any questions, there are a few comments in the chat box. One of them said that, what do you use? This is from Mr. Kosoko SB, PhD. Many thanks, Mr. Gada. Please, what do you use to separate the mean if the sample size is less than 30?
Okay, if it's less than 30, you want to use LSD, least significant difference, although LSD also does comparison, but it helps you to separate also. So LSD or 2-key, Bon Ferrari also will do the same. So you can use LSD, you can use 2-key, you can use Bon Ferrari. But once it's from 30 and above, the best is Duncan.
Sorry about that. I got thrown off, but were you able to answer the question?
Yes, I did. I did. I hope he got it, but I didn't hear any response of myself too.
Okay, all right. So thank you so much, everybody. Once again, this program was brought to you by the northern arm of the AutoAid National Research Hub, Nigeria, in conjunction with Penilua Educational Consults, that Mr. Agada heads, and the AutoAid Research Hub, National Research Hub Nigeria is domiciled in the Yaba College of Technology, specifically in the State Fund Center of Excellence. So thank you very much, everybody. Tomorrow we have a date. We're hoping we'll be able to start early. There will be a lot of hands-on and screen sharing. So please get ready. Please prepare to come with another system, as a phone is not likely to serve you as well as if you're working on a laptop. Thank you, everybody.
Thank you very much.